Hello, so now we're on to our last part of this exercise, just the calculations. We do have one more measurement to make, and that's the height of the image and the height of the actual object. So you can see the object on the left-hand side, the crossed arrow target. So, and you can see my pink circle. It's not the best circle in the world, but so let's actually measure the length of the circle. So let me put it on this side and then move the iPad so you can see it. All right. So it looks like it's about 1 centimeter. Is that about 1 centimeter? I'm trying to get it. Maybe right around 1. So 1 centimeter is the size of the target. Now let's actually see what the size of the image is. And I just moved it sideways from when I put it down here. So let's go see. Does it look about 3 centimeters to you? Or say 3 centimeters. All right. So how do we find the magnification? Well, remember from the previous exercise, to find the magnification, we took the height of the image, which is 3.0 centimeters, and divided by the height of the object, which is 1.0 centimeters. So that's obviously how much? 3 divided by 1, magnification of 3 times. Now, magnification is unitless. See the centimeters cross out. So if you're wondering about the units, there's none. There's crosses out. So 3, it's a ratio of 2 things. So now that we've got that magnification, this is a total magnification of the whole system. We're going to compare that with another calculation using the image and the object links. So we found 3 times for that magnification. So what I've done is I've drawn our apparatus. We have the object at 50 centimeters, lens 1 at 35.4. The image formed by that, lens 1 is at 20.4 and lens 2 at 5.4. So this is around our meter stick. What we have to now do is find the distances between these objects. So first of all, DO1 is the object distance for the first lens. Now that one was 14.6 centimeters, correct? 50 minus 35.4, so we did that in the previous video. And we also did the image distance. 35.4 minus 20.4, that's 15, correct? And that is the image distance of lens 1, so that's DI1. And the object distance for lens number 2, this image right here, it's a real image because it's going to be formed on the screen. It forms the object for L2. So this distance right here will be the object distance for lens 2. And that's 20.4 minus 5.4. Again, that's another 15 centimeters. Okay, 15.0 centimeters. And you gotta make sure you have the significant figures. The other one is 15.02. Just make sure you put the significant figures. And again, the precision, what's the precision of that? Plus or minus 0.1 centimeters. So it's 15.0 plus or minus 0.1 centimeters. And just make sure you put the precisions on your data table. So now let's actually just do a couple quick calculations of the magnification. Oh, I forgot to do the image distance for L2. What is the image that we saw? In the last video, we saw that image. And the image we assumed was of the object. So we want to find the distance from lens 2 all the way to the object. So how far away it is? 50 minus 5.4. And that is DI2, the image distance for lens 2. So that's 50.0 minus 5.4 centimeters. And what does that come out to be? That is 44.6 centimeters, correct? Right? So let's find the magnification of the system. If you have a two-lens system, the magnification is equal to magnification of lens number 1 times the magnification of lens number 2. Oh, that's a 2. Doesn't look like it, but it is. Magnification of 1 is the image distance over object distance for lens number 1. So M1 is DI1 over DO1. So check your data. What is DI1? That's 15 centimeters, right? 15.0 centimeters. DO2, that's 14.6 centimeters. So you can calculate that. So that's M1. The magnification M2, that's DI2 divided by DO2. In other words, it's the image over the object distance for the second lens. And again, we just had those. The image, remember that was the very long distance, 44.6 centimeters, and DO2 is 15.0 centimeters. And again, the centimeters all cancel out, so magnification becomes unitless. So what you do is you calculate these two values, then to find the total magnification, multiply M1 times M2 to find the total magnification of the two-lens system. That should be very close to 3.0, the magnification we got earlier. So again, do all that out, do the calculations, find the percent difference between the two magnifications, and you should get very close. All right, that's it for a microscope. So it's quite easy to make a microscope, two lenses, one shorter and one longer focal length.